So for honors physics, this is a review of trigonometry, and you might find it a little bit strange or fascinating the way I do it. Okay? I've had people say they hate it this way, or some people just love it. Okay? It's going to get cluttered. Draw this on your papers, please. So we have a right triangle with some angle theta, and then I like to call the sides little a, little b, and little c. They have special Greek names. Do you remember the names? Oh, what was that? Oh, that was the 5 minutes to get to lunch. In particular, C, the longest side, has a special name. Hypotenuse. Okay, we at least know what it's called. Okay. And if I'm talking about this particular angle, I didn't choose the apex angle at the top. I chose this angle near the bottom. Therefore, A is the adjacent side and B is the opposite side. Okay? So, then we have the basic functions that your calculator knows for every angle, right? It is doing a bunch of math to do them. All right, the sine of that angle is literally side B divided by side C. The cosine, sine is just an ancient Greek word for like a triangular inlet of water. Like they didn't have steep fjords because it's Greece, but they had sines. They call them shallow ones. That's why your sinus is called a sinus, because it's a triangular hole in your skull right there in the front. That's why. Okay? And then my favorite, the tangent, is the opposite side over the adjacent side. Okay? However, you may not be aware that there are inverses of all these functions. If you take the inverse sine, and so this will be angles in degrees. I might erase that. Degrees is out of 360 degrees. We'll get to the unit circle. The inverse sine of B over C equals the angle. And the inverse cosine, now you can take inverse sine and cosine of any number, but that does not equal an angle that we are studying in this problem. So watch out. Okay? It's just like any other function. You can inverse it. If you have the ratio, right, so we go from angle, these trig functions go from angles to ratios. That's very important. I'm going to erase that too. Right, so it's a ratio for any similar right triangle to that one, that represents that angle by a fraction. Okay, using a ratio or fraction. It's a number, it's not degrees. Okay, sine, cosine, and tangent are proportions relevant to that triangle with those specific angles and sides and any similar triangle. Does that make sense? Okay, because this is actually a tool with which we measure things in physics all the time, like our vectors that start bewildering people. Okay, so we got sines, and they have inverses. Let's see. Whoop. I need that a little bit smaller. I kind of want to leave my functions up. Back to blue. People said, oh, the unit circle. This is like the unit circle, but I hated the unit circle. It was terrible. Oh dear. What is a unit circle? Okay. Maybe. So, 8th hour fessed up and they said, oh, we had to have the end of trig online. And it was last year, and it was terrible. Because all you had to do was read stuff. Okay, yes, now we're getting somewhere. Okay, I needed to know that. I think they were deliriously tired or something, so they admitted that. Okay, so all we do, we have that classic triangle. That's why I'm drawing it this way, because we just superimpose the xy grid. Whoops, that should say minus x. We just take our xy axis, superimpose it on that triangle. Oh, and here's the xy directions that we want to study in physics. Okay? To make the unit circle, you just set c equal to exactly 1, because then if you're going to, if you want to use it, right, like I said, it's a tool for measuring all triangles and angles. So if you want a triangle that's bigger than 1, well, you just learn what the hypotenuse is and then you scale it up. You just multiply with a scalar for some bigger triangle. So we tend to just study the unit circle. Okay? So we set c to exactly 1, and then your unit circle nonsense was they were just trying to convince you to memorize a bunch of stuff. Like, so you can make any angle you want with different a's and b's, by which I mean like horizontal and vertical sides. You can make any angle you want, and you just set the hypotenuse to 1. Okay? Right. Okay. So the unit circle nonsense was just basically memorizing these triple sets of numbers for many helpful angles, wasn't it, Calvin? It was all a trick. Okay. Careful though, look. If c is 1, sine is just b, and cosine is just a. So if I have a squared plus b squared equals c squared, that literally also says that on the unit circle, sine squared, okay, and that means, I'll write it one time, that means sine of the angle, that ratio squared, sine squared of theta plus cosine squared of theta equals 1. And that's actually always true, because I could always divide my hypotenuse. And there's a whole bunch of other silly trig identities that derive from that one and from some other coincidences. Okay. So far so good. Oh, writing that down. I'm going to be rude and check the time on my phone. I really need the time. Okay. 7:45. Awesome. Okay. Let's see. I think for physics, I would rather modify. Oh, no. No, I wouldn't. I'll just show you. Hey. Okay. There's a nice chart. I'm going to do some select examples here. But I can just print you this chart on the test. Do you want to have common sines and cosines there? They give this for AP Physics. Okay. But what they've got, so like the only reason to study the unit circle would be to learn common values. And I like to like list them. Like if you have 30 degrees, then your sine of 30, cosine of 30, what else do we want? Maybe tangent? Sure. Okay. The sine of 30 is 1/2. Well, think about this. If that just means that's the sine is literally b over c. So that means we expanded our hypotenuse to 2, and my far side is 1. Well, I can solve the Pythagorean theorem. 2 squared is 4, minus 1 is 3. So then cosine must be square root of 3 over 2. And the tangent is just the ratio of this one over that one. So the denominators don't matter, they automatically cancel, and the tangent is just the square root of 3. Okay, these come up so often in physics that they're trying to trick you into memorizing them. But really, it's just a trick, because like 60 degrees is the complement of 30, and so its values are exactly reversed to that. See? Oh no. I did my tangents backwards, didn't I? Tangent of 30 is that one's 1 over root 3. No! See? Which is improper, I know. Once you know the secret to radicals, you can write it. You can write bad radicals too. Okay? The tangent is y over x, sine over cosine. So, it all ties in, and that's why I'm addicted or obsessed or whatever with writing all angles from the x-axis, because then it just becomes the unit circle, and your x is always horizontal, just like we want it, and it matches the chart exactly. If you keep flipping your angles around to wherever, like if you're going wild with your protractor or whatever, measuring anywhere, then blah. Then you have to take into account, okay, which is my opposite side now that I moved my measuring tool all the way around, and which is the adjacent side. And that's even more stuff to keep track of. And I just mix up tangents. Let's do one more that's my favorite. About 37 degrees, okay, that's the 3, 4, 5 triangle. So the sine is 3 over 5, the cosine is 4 over 5, and the tangent is 3 over 4. And its complement 53, they just trade places, and the tangent flips upside down. Okay, so they are literally just trying to get you to memorize those. But if you understand just, okay, I took Pythagorean theorem, I declared that these are the basic ratios, I can use my calculator anytime I want these guys in red, and there it is. Okay, that's where those tools come from. You rebuild it a couple of times in your mind, and then it's there. And you can just find your way through again. Is that better? A little bit. Okay. I should definitely stop the video now. Yes.